Hello everyone, this is Deshna and I'm so glad you're watching this video. You're currently watching a series in which me and my father try to solve a problem most of the drivers face, and that is blinding high beam headlights at 2-lane roads at night. In the last video, we talked about the idea we are moving on with and what exactly we're going to do to bring that idea to life. In this video, we'll be looking at certain LCD technologies and other technologies that will be suitable for smart shades.
So the first component that is required in the LCD is the backlight. The backlight provides illumination, however it's not required in the OLED as it emits enough light to be visible. And then comes the first layer of polarizer. So polarizer converts unpolarized light, which is normal light, into polarized light, which is light that oscillates in one direction only. So normal light typically oscillates in all the directions, however the direction of propagation is the same, and the polarizer helps plug out all the other unwanted directions of oscillations, and it only keeps one direction of oscillation. And after the first polarizer comes the liquid crystal layer. So this material is made up of a matter between solid and a liquid. They are rod-shaped molecules and they rotate the plane of polarized light according to the amount of electricity that is given to them. So it basically works like a gas stove, and it's typically made up of carbon, hydrogen, oxygen and nitrogen. And then comes the second layer of polarizer, which is typically used for filtering and to avoid leakages. And then finally comes the color filters if the LCD is polychromatic. So color filters exist in all the pixels and they're in the colors red, green and blue.
The first LCD that I have is the TFT module. TFT stands for thin film transistor. It works with tiny transistors and capacitors which control the amount of light which is to be entered through the liquid crystal layer. And then there are color filters to manage the amount of color. Because they have transistors and capacitors inside of them, they are relatively more expensive. They have a very high contrast and they have a fast response time. Then comes the character graphic LCD, which means they have both text and graphic elements. They usually have a read-only memory with predefined characters. They are usually made for displaying characters, however, it can also display graphics by manipulating individual pixels. Their quality is a bit low compared to other LCDs. They are a bit transparent, however, they need their PCB to function, so probably not suitable for smart shades. And they are very good for displaying characters. Next, we have COG LCD. COG stands for chip on glass, which means its integrated circuit is directly mounted onto the glass, so it does not require a PCB, which makes it less bulky and pretty ideal for something like glasses. Moreover, it is lightweight, it is cost effective and it does not have a high power consumption. And regarding its transparency, we took apart one COG LCD and I'm pretty surprised at its transparency, as you can see. So this part is adhesive, so ignore that, but this part is taken apart very carefully, and as you can see, it's very transparent. It's pretty impressive. And finally, we have the OLED. OLED stands for Organic Light Emitting Diode, and it's available in both passive matrix and active matrix. So it works this way, that there are electrons on one side and an organic layer on another side. The organic layer contains the holes for electrons to go in, so electrons are attracted to the organic layer. And once the current is passed through, the electrons jump into the holes and they emit light. And that's how the OLED works. Transparent OLEDs can achieve up to 80% transparency, however they are very expensive. They have a high contrast, wider viewing angles, and they don't need a backlight to function. Thank you so much for watching the video, and I hope to see you in another video. Until then, bye!